Hey stat students, happy Thursday morning. Good morning. You know, one of the best ways to get going when you have to work from home is you eat breakfast, you brush your teeth, you do your hair, you change out of your pajamas. Just get out of, do your usual routine, whatever that is. Do a little exercise, do some jumping jacks, some calf raises. Get that blood flowing, okay? Because we got sample means today. All right. So just a reminder about your homework. Some of you have asked me, like, are we turning this in? So as of this week, no. We're going to keep doing what we did all semester of not turning your homework. However, under these circumstances, we may change that. But I will not change that for this week. So you will not be turning this in. But please, please, please do this. Okay? I'm working on a quiz to give you either on Friday or Monday. We'll see about that, okay? Thank you again for your flexibility. Please email me anytime when you have questions, okay? And your questions actually help me figure some stuff out. So chapter 23, I told you that there's two main things that we need to be able to do: confidence intervals and hypothesis tests. And this is the same for all other tests. And let's just go over. We have we have two so far, and we're learning a third one this chapter. So we have a 1 proportion confidence interval and hypothesis test. We have a 2 proportion confidence interval and hypothesis test. And right now we're working on one sample mean, one mean. Okay, we have one mean confidence interval hypothesis test. So guess what's coming up next? You're right, 2 sample means. So I want to do one example with you. This is in your homework, number 31. It's about cars for all you car lovers. We're going to do a full hypothesis test. Look at page 531 in your textbook for a good example. I think it's 531 in the next couple of pages right there. But go ahead and pause the video and read through number 31. After you've read through it, let's pull out some of your given information. So we know that we're talking about car weights. We know that the mean, the population mean, which we'll use, not a good pen. The population mean, mu, is 3,000 pounds. So we believe that cars in the US, the average weight is about 3,000 pounds. So our sample mean, we took a sample of 91 cars, and our sample weight was 2,919 pounds. And then our standard deviation of our sample was 531.5 pounds. And then how many cars did we sample? We sampled 91 cars. So double check your work to make sure you have all that in there, okay? So let's go ahead and write our step 1, our hypotheses. Let's first define our x, okay, our x bar, or our mu. So our mu this time, okay, we're not using p, right? No because p is for population proportion. This is for a population mean. This is the true mean of, and if you look at that second sentence right there in your textbook, insurance companies are interested in knowing the average weight of cars currently licensed in the US. So true mean of weight of cars, and it's not just cars all over the world, it's cars currently licensed in the USA. Okay, you guys see that? And then now let's write our null and our alternative hypotheses. So our null is that mu is going to equal something, and then our alternative is mu something. Okay, so remember, this number is not our sample mean. You already wrote it right here. Our mu is what we are assuming to be true. We assume that the true mean of weight of cars currently licensed in the USA is 3,000 pounds. What we're trying to prove to see is if it's less than, greater than, or not equal to. Now read the last sentence in your given information. Is this strong evidence that the mean weight of all cars is not 3,000 pounds? So what is not? You guessed it, not equal to. All right, so that's step 1. So we're gonna go step 2. Step 2 is just like we've done so far. Just a reminder from yesterday. So we're not using certain like with the proportions, we're using nertain. The only difference is the n right here. And I'll show you how that works. Okay. So you need to talk about nertain, and you need your test, your alpha, and then your tails. Okay? So remember, the n stands for nearly normal. When you have the data, look at number 33 in that same page. You have the data, then you have to draw out a histogram. This one you don't. You don't know the weight, what the distribution looked like for those 91 cars in your sample. So this time we're just going to say, we assume the distribution of all cars licensed in the USA is nearly normal. And when we talk about normal, we're not talking about the opposite of abnormal. Remember, normal in statistics means a bell-shaped curve, that normal curve. Okay. Independence, we assume each car is independent. What's the definition of independent again? The weight of one car does not affect the weight of another car in this case. We assume, we don't assume, right? Because it's given and says there's a random sample. We just say there is a random sample of 91 cars. Okay, or we say each of the 91 cars was randomly selected, and our 10%. So we say we assume 91 cars is less than or equal to 10% of the population of cars currently licensed in the USA. How many pounds does your car weigh? Have you weighed your car? Okay, so here we go to TAT now. Oh, we gotta make sure we tell people we're gonna proceed with caution. Proceed with caution for several reasons, right? We don't know what the distribution looks like. We don't know if the cars are independent. We don't know if there are actually more than 910 cars in the US. Probably, right? Most likely, there are more than 910 cars currently licensed in the USA. But we're just gonna assume that. So our test is gonna be a one mean. Now we're not using a z-test, right? A t-test. Alpha, you choose. We'll just stick to our usual 0.05. And tails. Tails for now, I'm gonna leave this, but don't, yeah, just leave it and we'll come back to it. So for step 3 in our mechanics now, okay, I'm gonna do this in the calculator. Turn it on. So if you look at page 533, page 533, there are calculator commands that'll help you with this. Let me just double check it is 533. Yep, 533. Okay, so you're gonna go to stat, test, and I believe it's the second option, 2, where it says t-test. Stat, test, t-test, and then it's going to ask you for data or stats. Now, so data, again, the one on the left is where you have the raw data, and you're going to input that into a list. We don't have that for this question, so we're going to use stats. Okay, so I'm going to use, my mu is 3,000 pounds. My x bar, my sample mean is 2,919 pounds. My standard deviation of my sample is 531.5 pounds. My n is 91, and my mu null does not equal, my mu does not equal my mu null of 3,000, right? Let me change that right here. Calculate. I like the draw option now, because the draw option, you'll see, voila, you see it? It actually draws my two tails right there. So I'm gonna go back here and just write down tails, two tails. Okay, now most of you are able to see if it's one lower tail, one upper tail. This is your calculator will do it for you now. So we have to write down two things. Now this time we don't have a z-score, right? We have a t-score. Your t-score is negative 1.4538. And then your p-value is 0.1495. So since this is two tails, that means each of these tails, that tail, if this was less than right here, it would be half of this value. So the area under this curve, shaded region, is 0.07 something, and that's 0.07 something, okay? So we have to take that times 2, and these two areas are exactly the same as each other. All right, so now we have our p-value right here, so keep in mind, right? Are we gonna reject or fail to reject? So since the p-value of 0.1495 is greater than the alpha of 0.05, which one is it, class? We fail to reject the null hypothesis. We do we or do we not? We do not have evidence that the true mean weight of cars currently licensed in the USA is not equal to 3,000 pounds. So based off of our sample, let me just explain this. Based off of our sample, this average, this is not convincing evidence that our true mean weight is not 3,000. Okay? So can you just think about this some more? If this weight was lower, let's just say 2,800 pounds, it's possible that we would now have evidence of rejecting the null. We would reject the null and then we have evidence of the alternative. Okay, so maybe play around with that on your calculator. Put in 2,800 for your x bar and see what that happens. See if you would reject this time. Bonus question, because today's Thursday. If you were to make an error, I'm not saying you make an error, okay, don't be offended. If you made an error, what kind of error would you make here? A type 1 or a type 2? So remember, you're always looking at this part right here. Okay, you failed to reject, so the only type of error you can make is a type 2 error. Okay guys, see you soon.